Character encoding is one of those things that you don't have to deal with it until you do. And then once you do have to deal with it, there are a few little tricks that you need to know about in order to make debugging these types of problems easier. So here is a problem on Open XML Developer. This developer has used alt-chunk to merge rich text into a Word document, and it works, all except that it shows garbled characters. Well, this certainly looks like an encoding issue. Let's find out about what this is all about. So here is the whole description of the problem. There's a little bit of code up here. I can see that it's getting something from InfoPath, looks like, and then after it gets that from InfoPath, it then calls this method add rich text, which inserts the alt chunk element into the main document part. Well, the first thing to do here is just recreate his problem. When I have to do anything with alt chunk, I often go back to this blog post, how to use alt chunk for document assembly. In this post, I've assembled the very smallest amount of code necessary to implement a little bit of alt chunk functionality. So what I will typically do, here's a program right here. This does alt chunk with a word processing document. Down here is the alt chunk with HTML, and this from this using here all the way through these two braces. If you come up here and just replace that content right there with the using down below, that will let you see alt chunk with HTML. I'm not going to bore you with the details of grabbing all of this code and building the little example. It's pretty straightforward. If you can find the blog post at this link here, and it's worthwhile just to go through the exercise of building a little example. After doing all the necessary plumbing and Lego bricks to get everything working, here's the little example that recreates that developer's problem. So we have his exact code here to add the alt chunk data as a part and also to insert the alt chunk element. Up here, this HTML string, I copied that HTML string directly from his post right here. And this is actually going to be relevant. I'll show you why in just a minute. Other than that, everything just kind of hangs together. So let's run this little example. This example is looking for a document test.docx, and this document should have a content control in it. That's all that this little example requires. Here I've created a little document. I used the random text inserter to insert some random text. And then I went over here to developer and I clicked on this and added a content control. And that's all I did. I didn't do anything else. I didn't need to set any properties on the content control or whatnot. I just read through the example and could see that this would exercise the example as I wanted to. So let's close that and let's run our example. And here's our test.docx that now has the alt chunk. Now, I see something a little different than what he sees. I see this question mark here as opposed to his funny characters. Well, this I'll chalk up to different versions of Word, but obviously there's a little bit of garbage content in there. Well, let's see what that's all about. Next thing that I did is I went over here and I said, okay, here's the data right here. Here's that test data. So I'm going to come over here and I'm going to write. So every time I say write, I'm doing the right arrow, right arrow, right arrow, right arrow, right arrow, right arrow. And it didn't move. And then I do right arrow, right arrow. Go back, left arrow, left arrow, left arrow, left arrow. It didn't move, left arrow. So there's some kind of a funny little invisible character in there. Let's see what this is. I'm going to copy that little bit of text, and I am right here in Visual Studio going to create a new text file and paste that little teeny bit of code there. So I can go in here, left arrow. So yes, I'm right at the same location. There is that funny invisible character there, whatever that is. And now I'm going to File, and I am going to save this text file as, I'll call it text file 1.txt. That will work just fine. It tells me that some Unicode characters in this file could not be saved in the current code page. So let's do something else. Let's do a File and save text as. And what I want to do is I want to save with encoding. And what I want to do is I want to encode it with UTF-8. Now, one thing is that all of Open XML documents are always encoded in UTF-8. The main document parts are encoded in UTF-8, and all chunk pages are encoded in UTF-8. There may be places where you can use other encodings. I don't know, but I do know that encoding with UTF-8 works everywhere. So let's save that, and it did, in fact, save it. Now we've saved it as text file 1.txt. I now want to open it and look at it in binary. So I'm going to do a File and open a file. And there's my text file 1.txt. And what I'm going to do is I'm going to come down here and I'm going to tell it I want to open with. And what I want to open with is this binary editor. So one of the things that we can see here is right off the bat up here is we have the UTF-8 byte order encoding. That EFBBBF is the byte order encoding for UTF-8. If you're not familiar with BOMs or byte order encodings, a good place to read a bit about them is on Wikipedia. Is the byte order mark here. This byte order mark is a Unicode character that's used to signal the endianness or the byte order of a text file or stream. And the other thing that we will see down here is this UTF representation of the BOM is 0xEFBBBF. And if we come back here and EFBBBF, certainly that is the byte order mark for this UTF-8 file. If you are looking for a byte order mark in a Unicode file that is UTF-16, then you're going to see this U plus FEFF value up here, and we'll see that there in just a minute. So now I'm looking over here and I see, okay, there's my EFBBBF. And then I see there's my L and there's my I, and there is a greater than sign. And now I see this E2808B, and then I see this T on the test. So here is that funny character, E2808B. But the problem is it's kind of hard to figure out the Unicode code point for a particular Unicode character when you are looking at UTF-8. And that has to do with kind of this funny little way that UTF-8 enables a plain ASCII file to be a UTF-8 file, but then you can get out and get to all of the other characters that are in Unicode by having multiple byte sequences. I don't know all of those rules. I don't really care about all of those rules. I just know that they're there. If I ever actually have a need to learn about them, I will. But what I want to do now is I want to find out what the Unicode code point is for this E2808B. So now I am going to open that same file, text file 1.txt, and I'm going to do a File Save As. And again, I'm going to save with encoding. And I'm going to change this before I save it. I'm going to change it to text file 2 because I like my text file 1.txt. I might want to go back to it. I'm going to save this with encoding. And instead of saving it with Unicode UTF-8 with signature, I am going to save it with Unicode code page 1200. I could save it with Big Endian code page 1201. I don't really want to do that. Little Endian is just fine. I could show you Big Endian means that it puts the big byte on the end, And little endian means it puts the little byte on the end. So the big byte on the end means we have to reverse the values when we get them out. So I'll show you what that is. So I'm going to save it as Unicode code page 1200 and save it. So there's my text file 2.txt. Now let's open it in binary again. So I'm going to open text file 2.txt and I'm going to open it with the binary editor. And first thing we can see up here is now here's our FFFE. Well, actually it's FEFF because we are in little endian. So FEFF is what we're using. That's our byte order mark for this file. And there at 6C00, that's the L. And 0069, that's the I. And 003E, there is the greater than. And now I can see that funny character before the TEST. And the funny character is 200B. That 200B is pretty suspicious. I don't know what that character is. It's obviously a character that's outside of our normal range of characters that we expect in an HTML file. Normally we expect mainly ASCII characters. So let's go back to our browser, go to Bing, and I am looking for Unicode U plus 200B. And here is this zero width space. This is a really funny character. Who knows why this character is there? It looks like this zero width space is being returned by wherever this developer is getting their HTML text, from InfoPath or wherever he's getting it. Well, that zero width space, we certainly don't want it in there. It's a good question. I don't know why it's in there, but we probably just don't care. So now if we come back over here to our console application, and this response 1 here, I am going to say, write a little bit of code. Response 1 is equal to response1.replace. And the old, I'm going to use the string overload. The old string is U plus 200B. And the new string is nothing. I wrote this wrong. It should be /U200B. And now let's run this example and see what happens. Before I can run this example, I need to recreate this document. I'll create a new document test, open it up, put some random text in it, and I'll go to the Developer tab and insert a content control, save it, and close it. Now let's run our little example. Before I run it, I am just going to copy this test.docx and save it away. And it ran that quickly. And now let's open up test.docx. And sure enough, right here, we got rid of that garbage data. So that garbage character was a zero width space. Well, it's pretty strange to have such a character in there, but sometimes you don't have complete control over what you're getting from some other data source. If you're getting XHTML from some content management system, InfoPath or SharePoint or any of the other many CMSs that you can find out on the web, you don't necessarily know what you're going to get in that HTML. And if that HTML comes back with a zero width space in Unicode in there, well, you're going to have that show up in a inappropriate way in your Word document if you import that content using alt-chunk. One last point is this reminded me that this is similar to the FFFD character, and we want to get rid of that one too. So even though this wasn't an issue in this particular example, if we're going to get rid of the zero width space, then we also probably should get rid of that FFFD character. That FFFD character, let me look that up for you. It is the Unicode character replacement character. And I have also seen this when getting content from somewhere else, where if you've gone through some kind of encoding process, if the encoder sees a character that it doesn't understand, it sometimes will replace that character with this U plus FFFD. So now if we look at it, we've got this little bit of code right here to replace our U200B and our UFFFD with nothing. And then when we execute our application, we see what we really want to see after that content has been imported with alt-chunk. Key points about this process that I've showed you is you need to know how to look at an encoded document, if it's encoded with UTF-8 or if it's encoded with UTF-16. You need to know how to recognize that byte order mark that you're going to see at the beginning of the file. If you're looking at UTF-8 and you see a kind of an unrecognizable 3-character sequence, it looks like a Unicode character. Well, the easiest way that I've found to research that is to resave that file using Visual Studio from UTF-8 to Unicode. And then you can find out what the actual Unicode code point is for that funny character. And then you can go and use a search engine to find out about it on the web and then take appropriate action, either in this particular case, delete the character from our string before we do the importation or what have you. Well, that's all I'm going to cover in this video. Thanks for watching. Take care.